Right. Get out the old headphones here. Alrighty. Cool. Hello, everybody. I hope you are having a good day so far. My name is Michael. I am back. Let's go ahead and start the Twitch stream. Let me go to the Twitch. Make sure the title is. Nice. Okay, let me start the recording here for chapter 4. All right. Hello, everybody. Hello. We are back, jumping back into C Programming, a Modern Approach, second edition by K and King. Today, we're going to be reading. Bum, bum, bum. Chapter 4 Expressions. All right, so I hope you guys are ready to go for today. Let's just jump right on in to today's reading. I'm super excited to get started today and, keep the grind going. Let's try to just zoom in as much as we can here, make it as easy for you guys to see as possible. All right, this is going to be chapter 4 of C Programming a Modern Approach, second edition by K N King. Also, chapter 4 Expressions. The notes can be found on my GitHub, link down in the description below. This is going to be the condensed version. If you'd like to watch the full live stream, feel free to join me almost every single day around 7 p.m. PST as I teach myself computer science and programming from scratch. Thank you guys so much for being here. Let's go ahead and jump right on into C Programming a Modern Approach, second edition, chapter 4. Hey Feeds, how's it going? Trying to get a job in IT or tech? I don't know. Well, yeah, I guess it would be kind of fun if that happened. I don't know. I work as a biochemist right now, so no, there's no really pressures, but I do have other passions in life, and yeah, I kind of think it would be fun to do computer programming and stuff, software development. Okay, let's go ahead and get started with chapter 4 expressions. Again, I'm just going to be trying my best here to read through this. I've been at work all day, so please bear with me. And if I'm going to be uploading a condensed version, kind of like an audiobook, back to the channel as a video, so feel free to watch that if you don't want to stick with me kind of stuttering through this. It shouldn't be too bad though. Chapter 4 Expressions. One does not learn computing by using a hand calculator, but one can forget arithmetic. One of C's distinguishing characteristics is its emphasis on expressions, formulas that show how to compute a value rather than a statement. The simplest expressions are variables and constants. A variable represents a value to be computed as the program runs. A constant represents a value that doesn't change. More complicated expressions apply operators to operands, which are themselves expressions. In the expression a plus b times c, the plus operator is applied to the operands a and parentheses b star c parentheses, both of which are expressions in their own right. Operators are the basic tools for building expressions, and C has an Operators are the basic tools for building expressions, and C has an unusually rich collection of them. To start off, C provides the rudimentary operators that are found in most programming languages. Arithmetic operators including addition, subtraction, multiplication, and division. Relational operators to perform comparison, such as I is greater than 0. Logical operators to build conditions, such as I is greater than 0 and I is less than 10. But C doesn't stop there. It goes on to provide dozens of other operators. There are so many operators, in fact, that we'll need to introduce them gradually over the first 20 chapters of this book. Mastering so many operators can be a chore, but it's essential to becoming a proficient at C. In this chapter, we'll cover some of C's most fundamental operators, the arithmetic operators, section 4.1, the assignment operators in section 4.2, and the increment and decrement operators, section 4.3. Section 4.1 also explains operator precedence and associativity, which are important for expressions that contain more than one operator. Section 4.4 describes how C expressions are evaluated. And finally, section 4.5 introduces the expression statement, an unusual feature that allows any expression to serve as a statement. Okay, so let's just do some definitions here. An expression. Expressions are formulas that show how to compute a value. Right? And then the simplest expressions are variables and constants. So expressions are variables and constants. So variables, right, represent a value to be computed as the program runs. We know that. Simple enough. And constants, a constant representation, or constant represents a value that doesn't change. More complicated expressions apply operators to operands. So we have operators and operands, right? Operands, which are the expressions themselves. In the expression a plus b times c, the operator plus sign is applied to the operands a times b. So operators are symbols used to express meaning in code for arithmetic, etc. And then operands are the expressions themselves that are being impacted or influenced by operators. Let me take this here, throw this right in here. Operators, symbols that perform specific operations on values or variables. And operands are, okay, so I like that a little bit better. Right? And operands are the values or expressions on which the operands act. The operators act. Okay. Cool. Let's move on to the next page here. Four point one, arithmetic operators. The arithmetic operators, the operators that perform addition, subtraction, multiplication, and division, are the workhorses of many programming languages, including C. Table 4.1 shows C's arithmetic operators. plus unary plus minus unary minus, plus addition minus subtraction, multiplication, division, and remainder is percent. The additive and multiplicative operators are said to be binary because they require two operands. The unary operators require one operand. I equals plus 1, plus is used as a unary operator. J equals minus I minus used as a unary operator. The unary plus operator does nothing. In fact, it doesn't even exist in K and RC. It's used primarily to emphasize that a numeric constant is positive. The binary operators probably look familiar. The only one thing, the binary operators probably look familiar. The only one that might not is the percent, the remainder operator. The value of I percent j is the remainder when I is divided by j. For example, the value of 10 modulo 3 is 1. The value of 12 modulo 4 is 0. The binary operators in table 4.1, with the exception of modulo, allow either integer or floating point operands, while mixing allowed. When int and float operands are mixed, the result has a type float. Thus, 9 plus 2.5 float has a value of 11.5, and 6.7 float divided by 2 has a value of 3.35. The divide and modulo operators require special care. The divide operator can produce surprising results. When both of its operands are integers, the divide operator truncates the result by dropping the fractional part. Thus, the value of 1/2 is 0, not 0.5. The modulo operator requires integer operands. If either operand is not an integer, the program won't compile. Using 0 as the right operand of either the division, using 0 as either the, using 0 as the right operand of either division or modulo causes undefined behavior. Describing the result when division and modulo are used with negative operands is tricky. The C89 standard states that if either operand is negative, the result of a division can be rounded either up or down. For example, the value of negative 9 divided by 7 could be either negative 1 or negative 2. If I or j is negative, the sign of I modulo j in C89 depends on the implementation. For example, the value of negative 9 modulo 7 could be either negative 5 or 2. For example, the value of negative 9 modulo 7 could be either negative 2 or 5. In C99, on the other hand, the result of a division is always truncated toward 0. So negative 9 divided by 7, the value is negative 1. And the value of I modulo j has the same sign as I. Hence, the value of negative 9 modulo 7 is negative 2. So we'll just keep note for C99, as that's probably what we'll be using and above, which is kind of the modern behavior that we see today of integer division, where you have int divided by int truncates down, flooring the values, and modulo returns the actually, I've never actually done this one personally before, a negative modulo operation. Okay. Let's do 4.1. Tick. Operators. Hey Zen, how's it going? You got me motivated to stream again. I fired up my Twitch for the first time in months to go over some CS50 content. Nice, dude. You have to link it in the Discord or something. I'll have to check it out. That sounds awesome, dude. I appreciate the support, and I'm glad that I could help you out. Okay, operators that we'll do. Oop, let's just jot down some quick notes from this page. Arithmetic operators are operators that perform addition, subtraction, multiplication, and division. Right? And then we'll do unary, which is operators that only require one operand, and binary, so additive, so these are additive and multiplicative additive and multiplicative operators. And then binary, oh sorry, these are binary. So binary are, because they require two operands, operators that require two operands. So I'll take this chart here. We'll throw this guy in here. Hey, Coach Mo, how's it going? Yo, JB, what's going on, my boy? Welcome back in. It's good to hear from you again. How you guys been studying? What you guys been working on? Look how the project's going. How are they doing? Okay. Nice. So let's just do a quick, let's just do additive, which are going to be addition, which is going to be the plus sign, right? And then multiplicative, which is going to be, well, this is additive, so and then subtraction, right? Cool. Now we have multiplicative, which we have multiplication, we have division, and we have remainder. I'll say modulo. Right? So this is going to be, we'll just do this really quickly. Nice. So we'll say division, so let's just talk about the remainder. Well, it goes, numeric, do the same thing is used primarily to emphasize the numeric constant is positive. Remainder operators, the value of I, j is remainder. So this is just returns the remainder of I modulo I divided by j. So we'll say I modulo j returns the remainder of the quotient how do you spell quotient? I don't know. We'll find out. So the remainder modulo returns the remainder of the quotient. Right, so 4 goes into 12 evenly, so it's 0. 3 goes into 10 3 times with a remainder of 1. So division can produce surprising results. We'll say int divided by int returns or called integer division returns the floored value of the quotient. Right? And then here is like float int. This returns a float. Right? So when you do integer on integer, it truncates the results by dropping the fractional part or flooring it. So the remainder requires the operands to be requires both operands to be int. Okay. Using 0, right? You can't, because of undefined behavior, you can't divide by or modulo by 0. Ooh. Hey, Coach Mo doing C. Mass applying for internships, trying not to fail my classes, few personal projects. You know how it is. Nice, dude. Graph theory. Resume, Lee. Yeah, we might do a resume after this reading, but so I'm going to try to do the notes as we go here, so we don't have to do it at the very end. Okay, right, cool. And then obviously addition and subtraction are pretty self-explanatory. Adds two values together, subtracts two values, one another, multiplies two values together. I really spelled 2 like that. And the division is this. Okay. Cool. Page 55. Implementation defined behavior. The term implementation defined will arise often enough that it's worth taking a moment to discuss it. The C standard deliberately leaves parts of the language unspecified, with the understanding that an implementation, the software needed to compile, link, and execute programs on a particular platform, will fill in the details. As a result, the behavior of the program may vary somewhat from one implementation to another. The behavior of the division and modulo operators for negative operands in C89 is an example of the implementation-defined behavior. Leaving parts of the language unspecified may seem odd or even dangerous, but it reflects C's philosophy. One of the language's goals is efficiency, which often means matching the way that hardware behaves. Some CPUs yield -1 when -9 is divided by 7, while others produce -2. The C89 standard simply reflects this fact of life. It's best to avoid writing programs that depend on implementation-defined behavior. If that's not possible, at least check the manual carefully. The C standard requires that implementation-defined behavior be documented. Operator precedence and associativity. Those are some words. When an expression contains more than one operator, its interpretation may not be immediately clear. For example, does I plus j times k mean add I and j, then multiply the result by k? Or does it mean multiply j and k, then add I? One solution to this problem is to add parentheses, writing either I plus j times k or I plus parentheses j times k. As a general rule, C allows the use of parentheses for grouping in all expressions. What if we don't use parentheses though? Will the compiler interpret I plus j times k as parentheses I plus j close parentheses times k, or I plus parentheses j times k close parentheses? Like many other languages, C uses operator precedence rules to resolve this potential ambiguity. The arithmetic operators have the following relative precedence: highest order, plus minus unary, multiplication, division, modulo, and then lowest are plus minus binary. Operators listed on the same line, such as plus and minus, have equal precedence. When two or more operators appear in the same expression, we can determine how the compiler will interpret the expression repeatedly, putting parentheses around sub-expressions. Starting with high precedence operators and working down to low precedence operators. The following example illustrates the results. No parentheses in this expression, I plus j times k, is equivalent to this, where we have order of operations taking place, where the multiplication happens before the addition. Negative I times negative j is equivalent to parenthesis negative I by itself times parenthesis negative j by itself. Positive I plus j divided by k is equivalent to positive I within itself plus the operand j divided by k. Operator precedence rules alone aren't enough when an expression contains two or more operators at the same level of precedence. In this situation, the associativity of the operators comes into play. An operator is said to be left associative if it groups from left to right. The binary arithmetic operators, multiplication, division, modulo, plus, and minus, are all left associative, so I minus j minus k equals 2, combining the first one first into a single operand. Sub-operand, we'll say. And then this expression, I times j divided by k, is equivalent to making the first sub-expression wrap around that operand of equal precedence. An operator is right associative if it's groups from right to left. The unary arithmetic operators plus and minus are both right associative, so plus minus I is equivalent to minus parentheses plus I parentheses, which ultimately makes this a negative value if I is positive in itself already, which it is indicated by this value here. Precedence and associativity rules are important in many languages, but especially so in C. However, C has so many operators, almost 50, that few programmers bother to memorize that precedence and associativity rules. Instead, they consult a table of operators when in doubt, or just use plenty of parentheses. Okay, let's take some notes here on that real quick. Hey, how's it going, offline? Experience with APIs? A little bit. We have wrote some of our own and some of our own projects and tapped into a few public APIs like PubChem and stuff. It's been fun. I'm not that too knowledgeable, but I've done it a few times in Python with fast API and requests and stuff. Okay, so we want to talk about implementation defined behavior. So implementation defined behavior is behavior that arises when changes to the upgrades to the actual language itself, or like newer version, like version differences. So like version differences between languages or software, or maybe operating systems. Operating systems causing issues or interpretation / implementation behavior to become undefined or break for. Okay, let's throw this guy. Let's get some feedback on our kind of definition here. You're on the right track. Implementation defined behavior means the C standard allows certain aspects of the language to vary between different compilers, architectures, or operating systems, but requires that the implementation document how it behaves. So it's not undefined behavior where anything can happen, but rather predictable within a given implementation. The C standard allows certain aspects of the language to vary between different compilers, architectures, or operating systems, but requires the implementation document how it behaves. When the C standard allows compiler systems to decide how a particular feature behaves as long as they document their choice. The size in bytes of int, long, etc., whether char is signed or unsigned by default. The result of shifting a negative integer. Okay, so I'm sure we might get into this more because it says it talks about it more. Okay, operator precedence and associativity. Okay, so when an expression contains more than one operator, its interpretation may not be immediately clear. So this is like how operators the hierarchical structure of operators. How do you spell this? How I'm not gonna burn a tree for that. Hierarchical. I cannot spell this. The hierarchical structure of operators and how they interact with one another within an expression. There we go. Structure or physical layout of operators and how they interact with one another in an expression. Is that kind of a good definition? That's a solid starting point. Rules that determine the order in which operators in an expression are evaluated. Precedence defines which operators are evaluated first, while associativity defines the order of evaluation when operators are in the same precedence right together. Cool. Yeah, that's a good one. Okay, so then we want to talk about so this is, we'll say, operator precedence. Operator precedence rules resolve potential ambiguity. So this is the precedence defines which operators are evaluated first. While associativity defines the order of evaluation when operators are in the same precedence are put together. Cool. Nice. Nice. So now what we're going to say is there is in associativity, there's left associative, operator precedence is supposed to be left associative if it groups from left to right. Arithmetic operators are all left associative. Operators that group from left to right, and these are all arithmetic, right? Yeah. Which are like star divided by modulo plus and minus. Let's just wrap these guys in their little things here. There we go. So we'll do an example here. Oop. So let's do here right associative, which operators that group from right to left. And then these are the unary operators. These are binary arithmetic operators. Right? And then we'll just copy this really quickly. And then these are going to be unary arithmetic operators like plus and minus. Cool. And then let's grab a little screen grab of this guy here for an example. We'll go like this and say like example. Then I'll put this picture right here. Then we'll take example and throw that picture there. Nice. I watched a couple of videos now and I'm still quite confused on what the heck an API is. Yeah, so honestly, I'm not even like, I don't have like a formal definition for you, but from what I've understood, it's just a kind of like a, um, honestly, it's like it's as simple as like a URL. Honestly, it's kind of a special type of URL that has some meaning to it. And it's like you just tap into. It's like think of just like tapping into some server somewhere, and it's like and asking for some sort of request from that server, some data request that is previously set up to send you some data if received it. Think about it like I don't know, like calling a phone number and then um, or like I don't know, maybe like pinging, like calling a fax machine and then getting some fax or something rather than like calling a phone number. I'm not sure like the exact like raw definitions, but even for me, it's still a little like foggy. But in general, from my understanding, it's just the way that I think there's a lot of many different use cases too, not just what I've been explaining, but like you can just kind of tap into it. Uh, someone like a server. I mean, let's give me like a like get post put delete. It's a type of software interface offering a service to other pieces of software. Document or standard describes how to build such a connection. It's often made up of different parts with access tools that are available to the programmer. A programmer or programmer that uses one of these parts is said to be called portion. Okay. To hide, the purpose is to hide internal details of how a system works, exposing to only those parts a programmer will find useful and keeping them consistent with even internal parts later. An API may be custom built for a particular. An API opens a software system to interactions from the outside. It allows two software systems to communicate across a boundary and interface using mutually agreed upon signals. Right? So think you have like a server that's going to send you a bunch of chemistry information like PubChem, and I tap into it, and it's going to send me, whatever like any amount of data I requested. That's when with like it's like a conversation that you're going to ask it for, and it's like another way to expose your program to the outside world and to people to get at stuff like that. Okay, let's keep pushing. I do want to screen grab this one though. Which is the after we talk about precedence, right? Okay, cool. Hey Tenmei, it's been a long time. Yeah, I hope you've been. How you been? Hope you been. How you been? Welcome back. Hey Abdul, how's it going? Sometimes I think I'm saying the word too. Saying the word wrong too? Yeah, hierarchical, whatever. Okay, let's keep pushing and reading here. Let me get a drink of my drink real quick. Let me give the kitty a little back scratch and the puppy a little head scratch. Yep. Well, there you go. My lights are broken. I don't know what happened. Burnt out. Something happened. Okay. Computing a UPC check digit. Program. Computing a UPC check digit. For a number of years, manufacturers of goods sold in US and Canadian stores have put a barcode on each product. This code, known as a Universal Product Code, or UPC, identifies both the manufacturer and the product. Each barcode represents a 12-digit number, which is usually printed underneath the bars. For example, the following barcode comes from a package of Stouffer's French bread pepperoni pizza. The digits 0, 13800, 15173, and 5 appear underneath the barcode. The first digit identifies the type of the item, 0 or 7 for most items, 2 for items that must be weighed, 3 for drugs and health-related merchandise, and 5 for coupons. The first group of 5-digit items The first group of 5 digits identifies the manufacturer. 13800 is the code for Nestle USA Frozen Food Division. The second group of 5 digits identifies the product, including package size. The final digit is a check digit whose only purpose is to help identify an error in the preceding digits. If the UPC is scanned incorrectly, the first 11 digits probably won't be consistent with the last digit, and the store scanner will reject the entire code. Here's one method of computing the check digit. Add the first, third, fifth, 7th, 9th, and 11th digits. Add the second, fourth, 6th, 8th, and 10th digits. Multiply the first sum by 3 and add it to the second sum. Subtract 1 from the total. Compute the remainder when the adjusted total is divided by 10. Subtract the remainder from 9. Using the Stouffer's example, we get 0 plus 3 plus 0 plus 1 plus 1 plus 3 equals to 8 for the first sum, and 1 plus 8 plus 0 plus 5 plus 7 equals to 21 for the second sum. Multiplying the first sum by 3 and adding the second yields 45. Subtracting 1 gives 44. The remainder upon dividing by 10 is 4. When the remainder is subtracted from 9, the result is 5. Here are a couple of other UPCs in case you want to try your hand at computing the check digit. Raiding the kitchen cabinets for the answer is not allowed. Here's Jif creamy peanut butter, Ocean Spray jellied cranberry sauce. The answers appear at the bottom of the page. Let's write a program that calculates the check digit for an arbitrary UPC. We'll ask the user to enter the first 11 digits of the UPC, then we'll display the corresponding check digit to avoid confusion. We'll ask the user to enter the number in 3 parts: the single digit at the left, the first group of the 5 digits, and the second group of 5 digits. Here's what a session of the program will look like. Enter the first single digit, 0. Enter the first group of 5 digits, 13800. Enter the second group of 5 digits, 15173. Check digit is 5. Instead of reading each group as a 5-digit number, we'll read it as a 5 one-digit numbers. Reading the numbers as single digits is more convenient. Also, we won't have to worry that one of the 5-digit numbers is too large to store in an int variable. Some old compilers limit the maximum value of an int variable to 32,767. To read single digits, we'll use scanf with the %1d conversion specification, which matches a 1-digit integer. So we are going to include standard I/O in this code. We're going to have a main function where we're going to define a d, I1, 2, 3, 4, 5, J1, 2, 3, 4, 5. First sum, second sum, and total, all with our ints. Printf, enter the first single digit. We are going to scanf for a single digit and save that in D's pointer. We're going to printf, enter the first group of 5 digits, and we're going to scanf for 5 single digits and save those in I 1 through 5 pointers. Printf, enter second group of 5 digits. We do the same thing of 5 one-digit integer conversion specifiers with the J 1 through 5 pointer integer declarations. We then compute a first sum, which is d plus I, 2, 4, j, 1, 3, and 5. Second sum, I, 1, 3, 5, j2, j4. Total is 3 times first sum plus second sum. And we print f, saying the check digit is the inserted decimal, and we say printf, check digit is the inserted integer value, \n for a new line, and we're going to insert into there the expression 9 minus the total minus 1 modulo by 10 and return 0. Note that the expression 9 minus parenthesis total minus 1 parenthesis modulo 10 parenthesis could have been written as 9 minus total minus 1 modulo 10 with parentheses around total and minus 1 in the middle. But the extra set of parentheses makes it easier to understand. You're going to do this one, then take that value and do this, and then take that whole value and do 9 minus that whole thing, right? Just order of operations, if you are familiar with those from algebra. Cool, that was 4.1. Nice. That was actually a really good, I like that example. It's kind of similar to some of the examples that we did in the previous chapters, programming projects. So that one wasn't too abstract for us here. Cool. We are almost done with this chapter. Let's keep going. I don't think we're actually almost done, but oh yeah, we are almost done. I think it only goes to page like 60. Oh, I'm trolling. 66. Okay, assignment operators. Hey, Elfman, how's it going? Grind's going good. The stream is tough. Hey, Pirate, how's it going? I appreciate you coming in and joining the stream. This is C Programming, a Modern Approach by K.N. King, 2nd edition. You can find more information about it in my Discord link down below or in my profile on Twitch. Or you can find it on my GitHub too. I got a bunch of resources for you guys there. Cool. 4.2, assignment operators. Once the value of an expression has been computed, we'll often need to store it in a variable for later use. C's equal simple assignment operator is used for the purpose. C's equals to simple assignment operator is used for that purpose. For updating a value already stored in a variable, C provides an assortment of compound assignment operators. Simple assignment. The effect of the assignment v equals to e is to evaluate the expression e and copy its value into v. As the following example shows, e can be a constant, a variable, or a more complicated expression. So here we have I is equal to 5. I is now 5. We say j is equal to I. J is now 5. We say k equals to 10 times I plus j. K is now 55, which was 5 plus 5. No, it would be 5 times 10, which is 5 plus 5, 55. Right? If v and e don't have the same type, then the value of e is converted to the type of v as the assignment takes place. So if we have int I and float f, and I is equal to 7.299f, I is now converted to 72 from 72.99. Got truncated down into the integer form. And we say float 136. We say f is equal to 136. F is now 136.0. We'll return to this topic of type conversion later. In many programming languages, assignment is a statement. In C, however, assignment is an operator just like plus. In other words, the act of assignment produces a result just as adding two numbers produces a result. The value of an assignment v equals e is the value of v after the assignment. Thus, the value of I equals to 72.99f is 72, not 72.99. Okay. So we'll just do a simple assignment. The effect of assignment v equals to e is to evaluate the expression e and copy its value into v. Ooh. Cool. Nice. So let's just take this example here. That right there. Cool. So then if v and e don't have the same type, if v and e do not have the same type, then the value of e is converted to the type of v. Like this. Okay. And then we'll take this example here. Done. Nice. Hey, I'm in Khalif. How's it going? You got this, brother. Appreciate you. Hey, Josh, your dedication is admirable, bro. I think I saw your first stream like 8 months or so ago, and you're still going strong. We still grinding, man. We still grinding. Trust me. I've thought to myself, man, what am I doing here? But I just keep coming back because I'm honestly just like, what else am I gonna do, dude? I'm like, I don't know. Like, I don't. I'm kind of like stuck. I don't really have anything else like better to do, and I don't really have anything else like worse to do. Like I don't know if that makes any sense. Like I'm kind of just like in this limbo period of my life where I'm trying to figure things out and make some next moves and gain some skills to make those next moves. And I don't know, like, I, I don't know. Okay, let's keep pushing. Side effects. We don't normally expect operators to modify their operands since operators in the mathematics don't. Writing I plus j doesn't modify either I or j, it simply computes the resulting of adding I and j. Most C operators don't modify their operands, but some do. We say that these operators have side effects, since they do more than just compute a value. The simple assignment operator is the first operator we've seen that has side effects. It modifies its left operand. Evaluating the expression I equals 0 produces the result 0, and as a side effect assigns 0 to I. Since assignment is an operator, several assignments can be chained together. I equals j, which equals k, which equals 0. The operator equals operator. The equals operator is right associative, so the assignment is equal. The equals operator is right associative, so the assignment is equivalent to I equals to parenthesis j equal to parenthesis k equal to 0 parenthesis parenthesis. The effect is to assign 0 to first k, then to j, and finally to I. Watch out for unexpected results in chain assignment as a result of type conversion. Int I float f equals to I, which equals to 33.3f. I is assigned the value of 33, as we note above in our notes. Then f is assigned to 33.0, not 33.3 as you might think, because f is receiving the value of I, which I truncates 33.3 down to 33 because of its int declaration. In general, an assignment of the form v equals e is allowed wherever a value of type v would be permitted. In the following example, the expression j equals to I copies I to j. The new value of j is then added to 1, producing the new value of k. I is equal to 1, k is equal to 1 plus j equals to I. Printf, integer space integer space integer, new line, and insert I, j, and k. We set j equal to I in this k declaration, so j is equal to 1. We then add 1 to j to assign that to k, and so k becomes 2. So we print out 1, 1, and 2. Perfect. Yeah, I follow. Using the assignment operator in this fashion usually isn't a good idea. For one thing, embedded assignments can make programs hard to read. They can also be a source of subtle bugs, as we'll see in section 4.4. L values. Most C operators allow their operands to be variables, constants, or expressions containing other operators. The assignment operator, however, requires an L value as its left operand. An L value, pronounced L value, represents an object stored in computer memory, not a constant or the result of a computation. Variables are L values. Expressions such as 10 or 2 times I are not. At this point, variables are the only L values that we know about. Other kinds of L values will appear in later chapters. Since the assignment operator requires an L value as its left operand, it's illegal to put any other kind of expression on the left side of an assignment expression. I is equal to 12 is wrong. I plus j is equal to 0 is wrong. Negative I is equal to j is wrong. The compiler will detect errors of this nature, and you'll get an error message such as invalid L value in assignment. So let's go back up here and do side effects. Operators, actions that result operators that modify their operands. When an operator modifies their operand. The simple assignment operator is the first operator that has side effects. So a simple assignment, which is the equal sign. Simple assignment has side effects. It modifies its left operand. And I'll do example this. Okay, perfect. And as a side effect. Hey, thank you so much for that sub, Cyrus. I appreciate you. Hey, Brutal King, I get you. How's it going? How's it going? Cyrus, boy, I started the CS50 Scratch course as well. Nice, that's awesome. Are you following along with my series? I figured it'd be kind of a helpful tool for people wanting to take it along with someone. I get you. In due time, I think it will work out well for you. I don't see many people new to CS studying in depth like you. Instead, they use a lot of AI. And that's why I'm trying to distinguish myself. I'm trying to go against the grain a little bit. Obviously you need to like know about these tools and stuff, but um, I found success in other areas like in like stocks and investments and stuff. You know, you can find obviously you want to like you don't want to, you can ride the wave and find momentum, but there also is some value in kind of finding those needles in the haystack where people don't really want to go the needles because they're sharp and they're pointy and they're kind of scared of them. But if you can search for them and not be scared to put your hands in the haystack and dig down, um, you might be able to find some of these. I don't know. Hey Adele, how's it going? Okay, cool. Let's keep pushing here. Let's get some notes on L values. This is a term I have not heard before. L values. Put in chat if you've heard the term L value before. Okay, L values. So L values are just like places in associated to computer memory. Represents an object stored in computer memory. Right? So a variable is when we assign a variable, we talked about this last time when we talked about the heap and the stack. The variable goes onto the stack, right? Local variables inside a function are stored on the stack. Global zeros are stored in fixed area of memory. Persistent program's lifetime. So local variables go on the stack, global dynamically allocated on the heap until freed, right? Yeah. So I was talking about local variables. That's what I was referring to. So we can't assign like expressions. Expressions themselves aren't, stored in memory. They are evaluated at runtime against the operands which are in memory. Like, well, I guess this is an operand in itself, but these are two operands. So like the operands at their core at their lowest level, I'll say, right? Because you could have an entire operand if it was like an expression in an expression like a nested parentheses or something. Getting really niche here, but I'll say operands in their lowest form, right? Which are variables in this case, which are locally are assigned memory on the stack of the computer, and so got you. So L values. An L value, pronounced L value, represents an object stored in computer memory, not a constant or the result of a computation. Represents an object stored in computer memory, not a constant or the result of a computation. Variables are L values. Expressions such as this are not. Variables are L values. Expressions such as 10 or 2 times I are not. So I'll just take this little example here, put it in our notes. If you guys want access to these notes, they're in my GitHub. Feel free to give them a little star. They're really nice to look back on. I've looked back on them multiple times going through these practice problems, programming projects in the book and the end of chapter exercises, and it's really been helpful to go back through and see the markdown notes here, really formatted with examples, clear definitions. It's really nice. Okay, cool. So we didn't really go this deep to understand what L values exactly were when we were learning Python, but we kind of like knew that we can't, assign like expressions and stuff. It was kind of like inferred or assumed, like it's kind of like intuition in the learning, I guess. But now we know like it's called like L values on like a deeper level here. Okay. Compound assignment. Assignments that use the old value of a variable to compute its new value are common in C programs. The following statement, for example, adds 2 to the value stored in I equals to I plus 2. C's compound assignment operators allow us to shorten the statement and others like it. Using the plus equals operator, we simply write I plus equals to 2, which is the same as saying I equals to I plus 2. The plus equals operator adds the value of the right operand to the plus equals operator adds the value of the right operand to the variable on the left. There are 9 other compound assignment operators, including the following: minus equals to, multiply equals, divide equals, modulo equals. We'll cover the remaining compound assignment operators in a later chapter. All compound assignment operators work in much the same way. V plus equals to E adds V to E, storing the result in V. Same thing for minus, but it says subtraction. Same thing for V, but for multiplication. Same thing for division, but this is division. And then modulo, which is, modulo, computes the remainder when V is divided by E and stores the resulting in V, right? So it just performs the action of the initial value of E, it performs the action, right, of V with whatever operator and E, but just storing the result back in V. So just like on top of itself, perform this action and store the result back on itself. It's like in place addition. If you're familiar with Python's dunder I add, or like all those dunder I prefixed methods, that's how you implement your own operator overriding of those of these for your custom classes and stuff. Cool. So let's write down here compound assignment. Compound assignment operators allow us to shorten the statement and others like it. A shorthand way of computing in place arithmetic operations, right? A shorthand operator that performs an arithmetic or bitwise operation and assignment in one step, updating the variable in place. It's a good, I like that. So I'll say like here, we'll go take this guy for an example. Paste that there. And then we'll also grab this guy here. Do that here. Note that I've been careful not to say that V plus equals E is equivalent to V equals V plus E. One problem is operator precedence. I multiply equals J plus K isn't the same as I equals to I times J plus K. There are also rare cases in which V plus equals to E differs from V equals to V plus E because V itself has a side effect. Similar remarks apply to the other compound assignment operators. So there are some edge cases to look out for, such as like hidden side effects of the variable itself or operator precedence, for additional expressions happening after or in the same line as the in place operation. When using the compound assignment operator, Be careful not to switch the two characters that make up the operator. Switching the characters may yield an expression that is acceptable to the compiler but does not have the intended meaning. For example, if you want to write I plus equals j, but typed I equals plus j instead, the program will still compile. Unfortunately, the latter expression is equivalent to I equals to parentheses plus j, which merely copies the value of j positively into I. The compound assignment operators have the same properties as the equals to operator or simple assignment. In particular, they're right associative, so the statement I plus equals j plus equals k means that we're going to assign j to in place add on with k on top of it, and then do that value on top of I. Okay, yeah. Cool. Nice. Oh, 4.3 increment and decrement operators. Hey Adele, how's it going? Welcome back in. I learned about L values and R values like a year into using C++. Afterwards, everything made more sense. Nice, slow, yeah. Even local variables can use heap region. In general, yes, variables can go in the stack in general, and L value is what is getting assigned to, and the R value is what is getting assigned to. Is getting assigned, and the R value is what is getting assigned to. Vakam says, Michael, are you applying to jobs? I have not yet. I've applied to a few internal Python jobs at my internally at my own company, and I didn't even get a screening. So honestly, it's a little bit discouraging because the application process does take 15 minutes a pop. So to send out like 5 or 10 apps, you could be sitting there for like a good hour and a half, and then it's just to get no response, like even from like an internal application, like on a company like I've been able to produce a lot of really good results for within my division, and even like starting to develop software for my division, which isn't a software type division at all. So it's like I don't know, it's kind of a little bit frustrating and a little bit discouraging, and I honestly, when I did have that interview a couple months back for that dev job, but I just didn't really like the format of it. Like I got to go through like a 6 round interview process where I had to code in front of like 3 different people, like twice, just to like get denied at the end maybe, and do a take home problem just for like a kind of honestly like a minuscule bump in my pay right now. It's like I don't know, dude. It's well, it's a bump, but it's not like crazy crazy. It's like it's definitely would help a lot, but I don't know. I'm torn, dude. I'm torn. I don't want to like make it. I don't also want to like make it not fun anymore. Like I don't know. 4.3 increment and decrement operators. Two of the most common operations on a variable are incrementing, adding 1, and decrementing, subtracting 1. We can of course accomplish these tasks by writing I equals to I plus 1 or j equals to j plus 1. The compound assignment operators allow us to condense the statement a bit to I plus equals 1 or j minus equals 1. But C allows increments and decrements to be shorthanded even further using the plus plus increment and minus minus decrement operators. At first glance, the increment and decrement operators are sufficient itself. Plus plus adds 1 to the operator, whereas minus minus subtracts 1. Unfortunately, this simplicity is misleading. The increment and decrement operators can be tricky to use. One complication is that plus plus and minus minus can be used as a prefix operators. Plus plus I and minus minus I, for example, or postfix operators, I plus plus or I minus minus. The correctness of a program may hinge on picking the proper version. Another complication is that like the assignment operators, plus plus and minus minus have side effects. They modify the values of their operands. Evaluating the expression plus plus I, a pre-increment, yields I plus 1, and as a side effect, increments 1. Sorry. Another complication is that, like the assignment operators, plus plus and II have side effects. Oh my gosh, dude. Another complication is that, like the assignment operators, plus plus and minus minus have side effects. They modify the values of their operands. Evaluating the expression plus plus I, a pre-increment, yields I plus 1, and as a side effect, increments I equals to 1, printf, I is %d backslash n plus plus I, prints I is 2. Printf, I is %d backslash n, I prints I is 2. Evaluating the expression I plus plus, a post increment produces the result I, but causes I to be incremented afterward. I equals to 1. Printf, I is this, we call I plus plus. I is 1. Printf, I is here, insert I now, and I is 2. The first printf shows the original value of I before it's incremented. The second printf shows the new value as these examples illustrate. Plus plus I means increment I immediately, while I plus plus means use the old value of I for now, but increment it later. How much later? The C standard doesn't specify a precise time, but it's safe to assume that I will be incremented before the next statement is executed. The minus minus operator has similar properties. I didn't know this. I knew you could use the plus plus like you would to like obviously increment a value at the end of like a while loop to continue to the next phase. Um, but I didn't know you could use a prefix to increment it immediately to have it happen within an insertion of a format string or um, maybe you want to increment I directly within an expression right then and there rather than, waiting until the end. So you would do this if you want to go one further than the value of I. Right? You could, instead of saying parentheses I plus 1 right then and there, you could just do plus plus I within that expression. Okay, I could see how that would work. Okay, that's cool. I honestly miss these in Python. This is one thing when we learned C and CS50 that I was a little jealous of that we did not have. I equals to 1, printf, I is, and then we're going to do minus. So this is going to be 0. Perfect. Now we have I is 1, and we're going to do it later. Well, this one's going to print out just 1, and this one's going to print out 0. Perfect. When plus plus or minus minus is used more than once in the same expression, the results can often be hard to understand. Consider the following statements. I is equal to 1 and j is equal to 2. We're going to call k being equal to plus plus I plus j plus plus. So let's think about what's happening here. I is being incremented immediately in this expression, so we're going to increase I to 2. So this value is 2. J is being incremented after the expression happens, so we're going to use 2 at this point in time. And so this will be 2 plus 2, which I think will be 4. What are the values of I, j, and k after these statements are executed? Since I is incremented before its value, it's used, but j is incremented after its value. Oh, gosh, dude. What are the values of I, j, and k after these statements are executed? Since I is incremented before its value is used, but j is incremented after it is used, the last statement is equivalent to I equals to I plus 1, j, k equals to I plus j equals to j plus 1. So the final values of I, j, and k are 2, 3, and 4, respectively. In contrast, executing the statements, I equals to 1, j equals to 2, and k equals to I plus j plus will give us 3 for k. Perfect. We'll give I, j, and k values of 2, 3, and 3, respectively. For the record, the postfix versions of plus plus and minus minus have higher precedence than unary plus and minus and are left associative. The prefix versions have the same precedence as unary plus and minus and are right associative. Cool. That's actually really neat to know. I did not know that, and I will definitely be using that. in some of our C projects going forward. I do like this shorthand. Let's see here. Increment. We'll say incrementing, adding 1, a value of 1. We'll say decrement, adding or subtracting a value of 1. Right? Now we how should I take notes here? So incrementing. So we'll say ways to increment / decrement 1. Var equals to var plus 1. Right? 2. Or we'll copy this and say, or -1. Right? Then we can do 2 compound assignment, which is to var is equal to var plus equals foo. Oh, 1. Sorry. What am I doing? Drolling. Or var minus equals 1. Hold on, I want to go back to what it said about, yeah, if you flip them, you're just assigning the operator to the positive or negative value of that variable. Okay, then 3 is var plus plus or plus plus var or var minus minus or, oh my goodness, come on Mike, why can't I type? Minus minus var. Actually, we'll take the prefixes and list them out first. So, or okay, there we go. So we're going to go talk about prefix and postfix. Prefix and postfix operators. We're going to do plus plus or and minus minus. So these guys, prefix operator, prefix will perform the desired operation immediately on the variable before computing. Well, it has precedence, right? So it said that the postfix versions have higher precedence than the unary plus minus, but the prefix versions have the same precedence. So the prefix are the same as unary plus minus. Prefix will perform the desired operation immediately on the variable before, right? Or we'll say that, and then postfix will performs the desired operation after the current expression or line completes. Something like this. So incrementing adds 1 to a variable, and decrementing subtracts 1 to a variable. Ways to increment slash decrement. Basic arithmetic is this. Compound assignment. Okay, well, maybe we can make this a little bit better. So 1 basic arithmetic. And then we'll do, can we do like C? Like such, and then take this, open this, or is it C? I always forget. Who's got it for me? Who's got it for me? How can you do the code block? This might be it. This might be doing it. Yeah, it is. Okay. So this is going to be. It's going to be. Right. Perfect. Nice. So 2 is going to be compound assignment. And then we're going to copy kind of this code block here, do here. It's going to be var plus equal 1, var minus equal 1. And then we have increment, decrement operators. Increment slash decre. Right, and then what we'll do is I'm just going to copy this code block. I'm going to do dash 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 C dash 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 paste. Boom. Like that. Cool. Get rid of this. So we'll say prefix so prefix and postfix operations. So the prefix modifies the variable before the value is used in expression. And then postfix. So this file. Okay, yeah, so let's do an example here. We'll go. This guy here. Nice, and then we'll do postfix. The variable is modified after its current value is used in the expression. Yeah, I like that. And we'll take this, put this here. Oh, no, we'll take all of this, put this right there, this back, and then copy this. Nice. Awesome. Let's catch up on some chats here. Yeah, Python has that walrus operator. I often forget when to use that one. What made you want to learn C? I wanted to get better at Python. So I wanted to understand why my Python code was running, what was actually going on, how it was interacting with the computer. I wanted to maybe write my own libraries in C to then import into Python, and see if I could make my code faster, maybe for like the stuff I wrote at work, like my matrix solver. I wrote at work and stuff for my chemical matrix solver. Yeah, so I could like see what I could do with that. I don't know. Could be fun. It's kind of funny to see someone else studying because it's literally how I do it. But I say what every 30 seconds. Yeah, trying to keep it a little clean here for everybody. Yeah, I appreciate you coming in. But yeah, same, just internally. Josh, how's it going? How do you study all day? I say, is there like a number as long as you are feeling? How long do you study a day? I usually try to do at least an hour to an hour and a half after work, or I feel pretty guilty that I didn't come on and study for you guys. But um, I'm on kind of a flow right now, so we're almost kind of through with the chapter. So I'm probably going to just go probably for till about 2 hours. I think it'll take us to get. We're at hour 36 right now. Okay, cool. So that looks pretty good for my notes. Oh, that looks solid. Look at that. That looks really good. That looks really, really good. Yeah, these notes are found on my GitHub if you guys want them. Make sure you guys hit it with a star. Hit it with a star. I'm a star. You guys know what movie that's from? It's a recent one. Not super recent, but last couple years. Okay, well, I gotta stand up though. My leg's falling asleep. I gotta shake it up. My leg's falling asleep though, bad. Okay. Kitty's looking at me like, what's going on? Yeah, my leg is falling. I gotta get a better chair, you guys. If you guys have recommendations for a better chair, I literally found this one. Someone was throwing it away. It was sitting out by the dumpster out in my apartment complex. It was literally like almost brand new looking. I just took some soapy water and I soaked the seat in the tub and let it dry out over the summer for a couple days. And I got myself a cool little just a desk chair that works perfectly fine. But I want to be honest with you guys, for streaming and doing long sessions, I want to get something that's a little bit more supportive on the old cheeks, on the rump. It's my legs are falling asleep when I sit here for too long, and my butt starts to hurt. Okay. What's up, Ray? Ray's back again, like usual. My boy Ray. Ray's always in here. Appreciate you coming back in, Ray. You guys are in the stream right now. If you guys could leave a like on the stream, we got 20 people in here. Thank you guys so much for being here. If you're new, my name is Michael. I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist professionally, where I manufacture biological controls that sell for multi-millions of dollars, and I kind of specialize in some of our most advanced products on our product line, and I've really been starting to implement software into the product line and stuff like that. So been really trying to learn software and see what I can do with it. So yeah, I appreciate you guys being here and joining me. Let's keep on going. We're reading C Programming: A Modern Approach, second edition right now. I'm trying to learn C to better improve our skills in programming and in Python in general. And so yeah, I appreciate you guys being here and joining me. We're reading chapter 4. We're almost done here. A couple more sections. Expression evaluation. The table 4.2 summarizes the operators we've seen so far. Appendix A has a similar table that shows all operators. The first column shows the precedence of each. So we have increment and decrement postfix, which has top precedence and left associativity. Second precedence is increment, decrement, prefix, unary plus, unary minus, right? Third precedence is multiplicative, left, fourth precedence is additive, left, and fifth precedence is assignment, right, associative. The first column shows the precedence of each operator relative to the other operators in the table. The highest precedence is 1, the lowest is 5. The last column shows the associativity of each operator. Table 4.2, or its larger cousin in Appendix A, has a variety of uses. Let's look at one of these. Suppose that we run across a complicated expression such as A equals to B plus equals to C plus plus minus D plus minus minus E divided by minus F. As we're reading someone's program. This expression would be easier to understand if there were parentheses to show how the expression is constructed from sub-expressions. With the help of table 4.2, adding parentheses to an expression is easy. After examining the expression to find the operator with the highest precedence, we put parentheses around the operator and its operands, indicating that it should be treated as a single operand from that point onwards. So the operator with the highest precedence would be the postfix C++ here. We then repeat the process until the expression is fully parenthesized. In our example, the operator with the highest precedence is the plus plus, used here as the postfix operator, so we put a parentheses around the plus plus and its operand. Perfect. We now spot a prefix minus minus operator and a unary minus operator, both precedence 2 in the expression. So this one gets parentheses and this one gets parentheses. Note that the other minus sign has an operand to its immediate left, so it must be a subtraction operator, not a unary minus operator. Talking about this one here. Next, we notice the division operator, precedence 3, and wrap that whole expression or sub-expression for these two operands. The expression contains two operators with precedence 4, subtraction, and addition. Whenever two operators with the same precedence are adjacent to an operand, we've got to be careful about associativity. In our example, minus and plus are both adjacent to D, so associativity rules apply. The minus and plus operators group from left to right, so parentheses grow around the subtraction first, then the addition. So you would put the parentheses around here, and then around the entire thing there. The only remaining operators are equals and plus equals. Both operators are adjacent to B. So we must take associativity into account. Assignment operators group from right to left, so parentheses go around the plus equals to operator first, or sub-expression, and then around the entire expression. So it would be this guy, right? Yeah, so it'd be this guy, then this guy and this guy, then this guy, then this guy and this guy, then this guy, then this guy. The expression is now fully parenthesized. I think it would be kind of a fun maybe program for us to try to write in C to auto-generate these parentheses expressions. I know that there's some type of practice problems on LeetCode and things like that that kind of involve a stack and make in evaluating whether or not it's fully parenthesized and it's not. But we could maybe have in this order of operations table within our C program, and we could write a program to actually do this precedence and associativity, which maybe that would be some good practice. Cool. So this is kind of just some, this was honestly just some practice with expression evaluations, kind of hitting back home on what we talked about in the previous sections with one kind of big example. So not much notes on this one, as it was just kind of putting into practice what we had learned in the past year, all at once. Order of subexpression evaluation. The rules of operator precedence and associativity allow us to break any C expression into subexpressions to determine uniquely where the parentheses would go if the expression were fully parenthesized. Paradoxically, these rules don't always allow us to determine the value of the expression, which may depend on the order in which its subexpressions are evaluated. C doesn't define the order in which subexpressions are evaluated, with the exception of subexpressions involving the logical and, logical or, conditional, and comma operators. Thus, in the expression parentheses a plus b close parentheses times parentheses c minus d close parentheses, we don't know whether a plus b will be evaluated before c minus d. Most expressions have the same value regardless of the order in which their subexpressions are evaluated. However, this may not be true when a subexpression modifies one of its operands. Consider the following example, where a equals to 5 and b equals to a plus 2 minus a equals to 1. So within this expression alone, we modify the value of a to become 1. So we don't know whether the value of a here is 1 or 5, depending on whether this subexpression is evaluated before this subexpression. Now my guess is that it's going to say, I'm just going to allude here, my thinking is it's going to work from right to left to read our code just as Python does, and it'll probably assign this one first, but we'll see. The effect of executing the second statement is undefined. The C standard doesn't say what will happen. With most compilers, the value of C will be either 6 or 2. If the subexpression b equals to a plus 2 is evaluated first, b is assigned to the value of 7 and c is assigned to 6. But if a is equal to 1, is evaluated first, then b is assigned to 3 and c is assigned to 2. Okay, so it depends upon the standard of C you're using and the compiler's interpretation of how it's set up to read these expressions. Interesting. Avoid writing expressions that access the value of a variable and also modify the variable elsewhere in the expression. Avoid writing expressions that access the value of a variable and also modify the variable elsewhere in the expression. The expression b equals to a plus 2 minus a equals to 1 accesses the value of a in order to compute a plus 2 and also modifies the value of a by assigning it to 1. Some compilers may produce a warning message such as operation on a may be undefined when they encounter such an expression. To prevent problems, it's a good idea to avoid using the assignment operators in subexpressions. Instead, use a series of separate assignments. For example, the statement above could be rewritten as a equals to 5, b equals to a plus 2, a now becomes 1, c equals to b minus a. The value of c will always be 6 after these statements are executed. Interesting. So I'm going to just copy this little picture here and say, I want to throw it on here. I'm not exactly sure what I want to say for the comment on it. Probably I'll think it over here. Hey Tim, how's it going? You here for the graveyard shift? We've been going for hour 48 here, so we've been grinding. We're almost there though. We're almost there. I keep saying that, but we're truly almost there. Beside the assignment operators, the only operators that modify their operands are increment and decrement. When using these operators, be careful that your expressions don't depend on a particular order of evaluation. In the following example, j may be assigned to one of the two values. I equals to 2, j is equal to I times I plus plus. Well, I is equal to 2 here, and I is also equal to 2 here. In this expression, it will be incremented afterwards. So will this be I is equal to, this is just to j is 4? It's natural to assume that j is assigned to the value of 4. However, the effect of executing the statement is undefined, and j could just as well be assigned to 6 instead. Here's the scenario. The second operand, the original value of I, is fetched. Then I is incremented. 2. The first operand, the new value of I, is fetched. 3. The new and old values of I are multiplied, yielding 6. Fetching a variable means to retrieve the value of the variable from memory. A later change to the variable won't affect the fetch value, which is typically stored in a special location known as a register inside the CPU. So it could be just as well assigned to 6. The second operand, the original value of I, is fetched. Then I is incremented. So I is fetched and then incremented. The first operand, new value of I, oh, so if it fetches this value and then updates it in this, it updates it and then calls it in here. So it would be 3 times the original value here of 2 gives you 6. Oh, okay, I get what it's saying. So it fetches this value in this phrase here. And then it comes over here and reads it. Well, what is I after it was fetched here? Well, it was 2. Well, then to come back to this, no, maybe it's the other way around. Like in terms of like, it's the same kind of thinking, but it's like, so I is fetched in this kind of phrase here, right? In this kind of phrase. This value then reads as 2 because it's fetched here. But because this has postfix incrementing going on, when an I is, fetched in this place here, it fetches that incremented I, that new incrementation. So this value becomes 3, and this is that original 2, giving us j equals to 6. Ah, we got it. Right, okay, so one more time, you guys. This is postfix incrementing, meaning that the plus plus comes after the I, meaning that when we fetch the value of I, it will keep the original value and then afterwards be incremented, for future use. So when we fetch it, we get the value of 2. And then it's updated to 3. And we call that 3 value when we fetch this variable here. If we were reading this from right to left, which sometimes, like it's saying, it's undefined how the compiler will, or whatever compiler you're using, will reinterpret these expressions. So 3 will be fetched here, giving us 3 times the original value of 2. Now, if we were to call I again down here, I, for whatever calls, would be 3 unless we increment it later, right? Because it was changed here. But this is still the original value of I. Nice, I like that. So I'm going to take this one as well. I'm going to say copy. I'm going to go like here. I'm going to say it might seem obvious to think j equals to 4, but j has undefined behavior depending on the interpreter, or depending on the compiler, etc. If the expression was read left to right, I++ would fetch I would fetch I equals to 2, and then place that value within the expression at that place. Then due to the postfix nature of plus plus, I is increased to 3. Right? When the next single I variable is fetched, it now has a value of 3. Thus giving us the expression, the simplified expression of j is equal to 3 times 2, which is equal to 6. This is for I equals to 2, j is equal to I times I plus plus. Exactly. You might think that it evaluates left to right, like I is the first operand is 2, I plus plus is the second operand. It's also 2 with postfix uses 2, then increments to 3, so it's 2 times 2 is 4, and then I becomes 3. But that's not guaranteed because of sequence points and undefined behavior. Modifying and reading the same variable I more than once without an intervening sequence point leads to undefined behavior in C. Why undefined behavior? In j equals to I times I plus plus, I plus plus modifies I, then I reads I. There's no sequence point between those two actions, so the compiler is free to evaluate the left first or evaluate I plus plus first or even interleave them. Thus, the results can vary between the two compilers. So I'm going to say like, rephrase this, keep my backticks stuff. It might seem straightforward to assume j is equal to 4. Okay, whatever. But in reality, I is equal to 2, I plus plus, I is fetched, j is equal to 3. Nice. Cool. I feel good about that. What was your method through the practice questions? The videos only seem to cover so much. What was your method of getting through the practice questions? Oh, man, CS50X is my go-to, bro. What was your method getting through the practice questions? The videos only seem to cover so much, and then when you're going through the problems, it feels very difficult to come up with a solution. They use guardrails in the AI to guide you through the logic of the problem without giving you the answer they implemented a year ago. I got stuck on a days where problems are completely normal to me. Yeah, I got stuck for I took sometimes 5 6 hours to solve some of those problems, and I did use the duck debugger and AI to help me through them and talk through my stuff. I'm completely guilty of using that tool to understand my code because yes, I do agree with you. It's very difficult to just watch those videos having no C or coding background, especially if you have no coding background at all, not even CS50P. Watch those videos and jump into those problems and those like those code bases, like those already structured problems, and kind of understand what's going on. It's very daunting. Having unfamiliar, not like being unfamiliar with like being able to keep track of maybe like a little bit larger of files and more like more than one custom like function and something like that. So like it can be pretty difficult. Honestly, my best advice for those problems is to just really take the time to just read the entire code base before you begin. Um, I felt that if I did that before I kind of jumped in, it would have helped me really, understand it a lot better. So that's what I've been doing for my MIT open courseware coursework is that I've been really reading the entire problem set, all of the methods that it gives me in the class structure before I actually start modifying the classes and making them my own and whatnot and solving the problem. So I know exactly all the methods I have on hand to use, like and whatnot, because like it just makes things easier if you're not having to like think about like how to solve the problem and also what the problem is solved like asking you. It's like that's just making it even harder on yourself. Okay, so we are on page 65 and we need to get, okay, we're almost there. We're so close. Jeez. 2 hours, guys. We're on 2 hours. Thank you guys for being here. If you guys are enjoying the reading and the live stream, leave a like on the stream. I really appreciate it. Appreciate you guys being here and hanging out with me in this study session. Undefined behavior. According to the C standard, statements such as C equals to B equals to A plus 2, minus A equals 1, and J equals to I. Oh, thank you so much for the follow. Who is that? I forgot to open up my Streamlabs here. Hey, did we hit a goal? I think we hit a goal. um, Zaname followed us. Thank you so much. Thank you, Cyrus, for the follow on YouTube as well. Cool. According to the C standard, statements such as C equals to B equals to A plus 2 minus A equals to 1 and J equals to I times A plus plus cause undefined behavior, which is different from implementation defined behavior. When a program ventures into the realm of undefined behavior, all bets are off. The program may behave differently when compiled with different compilers, but that's not the only thing that can happen. The program may not compile in the first place. If it compiles, it may not run, and if it does run, it may crash, behave erratically, or produce meaningless results. In other words, undefined behavior should be avoided like the plague. 4.5. Expression statements. C has the unusual rule that any expression can be used as a statement. That is, any expression, regardless of its type or what it computes, can be turned into a statement by appending a semicolon. For example, we could turn the expression plus plus I into a statement, plus plus I, semicolon. When this statement is executed, I is first incremented, then the new value of I is fetched, as though it were to be used in an enclosing expression. However, since plus plus I isn't part of a larger expression, its value is discarded and the next statement executed. The change to I is permanent, of course. Since its value is discarded, there's little point in using an expression as a statement unless the expression has a side effect. Let's look at 3 examples. In the first example, 1 is stored into I, and then a new value of I is fetched but not used. In the second example, the value of I is fetched but not used. However, I is decremented afterwards. In the third example, the value of the expression I times j minus 1 is computed, then discarded. Since I and j aren't changed, the statement has no effect and therefore serves no purpose. A slip of the finger can easily create a do-nothing expression statement. For example, instead of entering I is equal to j, we might accidentally type I plus j. This type of error is more common than you might expect, since the equals and plus character usually occupy the same key on the keyboard. Some compilers can detect meaningless expression statements. You'll get a warning such as statement with no effect. And the Q&A. Let's go ahead and read the Q&A, and then we'll be done for today. Q&A. I noticed that C has no exponential operator. I noticed that C has no exponentiation operator. How can I raise a number to a power? Raising an integer to a small positive integer power is best done by repeated multiplication. I times I times I is I cubed. To raise a number to a non-integer power called the POW function. I want to apply the modulo operator to a floating point operand, but my program won't compile. What can I do? The modulo operator requires integer operands. Try the fmod function instead. Why are the rules for using division and modulo operators with negative operators so complicated? Why are the rules for using the division and modulo operators with negative operands so complicated? The rules aren't as complicated as they may first appear. In both C89 and C99, the goal is to ensure that the value of A divided by B times B plus A modulo B will always be equal to A. And indeed, both standards guarantee that is this in this case, provided that the value of A divided by B is representable. The problem is that there are two ways for A divided by B and A modulo B to satisfy this equality if either A or B is negative. As seen in C89, where either negative 9 divided by 7 is negative 1 and negative 9 modulo 7 is negative 2, or negative 9 divided by 7 is negative 2 and negative 9 modulo 7 is 5. In the first case, negative 9 divided by 7 plus, oh my god, dude. In the first case, negative 9 divided by 7 times 7 plus negative 9 modulo 7 has the value of negative 9. In the second case, negative 9 divided by 7 times 7 plus negative 9 modulo 7 has the value of negative 9. But these operands or sub-expressions are different. By the time C99 rolled around, most CPUs were designed to truncate the result of division towards 0, so this was written to the standard as the only allowable outcome. If C has L values, does it also have R values? Yes, indeed. An L value is an expression that can appear on the left side of an assignment, and an R value is an expression that can appear on the right side. Thus, an R value could be a variable constant or more complex expression. In this book, as in the C standard, we'll use the term expression instead of R value. You said that V plus equals E isn't equivalent to V equals V plus E if V has a side effect. Can you explain? Evaluating V plus equals E causes V to be evaluated only once. Evaluating V equals to V plus E causes V to be evaluated twice. Any side effect caused by evaluating V will occur twice in the later case. In the following example, I is incremented only once. So, A at index I plus equals 2. If we use equals instead of plus equals here, here's what the statement will look like. A at index I plus is equal to A at index I plus 2. So it'll increase the position and then, gotcha. The value of I is modified as well as used elsewhere in the statement, so the effect of executing the statement is undefined. It's likely that I will be incremented twice, but we can't say that will certainly happen. Okay, question. Why does C provide the plus and minus operators? Are they faster than other ways of incrementing and decrementing, or are they just more convenient? C inherited plus and minus from the Ken Thompson earlier B language. Thompson's apparently created these operators because his B compiler could generate a more compact translation for plus I rather than for I equals I plus 1. These operators have become a deeply ingrained part of C. In fact, many of C's famous idioms rely on them. With modern compilers using plus and minus won't make a compiled program any smaller or faster. The continued popularity of these operators stems from mostly their brevity and convenience. Do plus and minus work with floats? Yes. The increment and decrement operations can be applied to floating point numbers as well as integers. In practice, however, it's fairly rare to increment or decrement a float variable. When using the post version of plus or minus, Just when is the increment or decrement performed? That's an excellent question. Unfortunately, it's also a difficult one to answer. The C standard introduces the concept of sequential point and says the C standard introduces the concept of sequence point and says that, quote, updating the stored value of the operand shall occur between the previous and the next sequence point. There are various kinds of sequence points in C. The end of an expression statement is one example. By the end of an expression statement, all increments and decrements within the statement must have been performed. The next statement can't begin to execute until this condition has been met. Certain operators that we'll encounter in later chapters, logical and, logical or, conditional and comma, also impose sequence points. So do function calls. The arguments in a function call must be fully evaluated before the call can be performed. If an argument happens to be an expression containing a plus plus or minus minus operator, the increment or decrement must occur before the call can take place. What do you mean when you say the value of an expression statement is discarded? By definition, an expression represents a value. If I has a value of 5, for example, then evaluating I plus 1 produces the value of 6. Let's turn I plus 1 into a statement by putting a semicolon after it. When this statement is executed, the value of I plus 1 is computed. Since we have failed to save this value or at least use it in some way, it is lost. But what about statements like I equals to 1? I don't see what is being discarded. Don't forget that equals is an operator in C and produces a value just like any other operator. The assignment, I is equal to 1, assigns 1 to I. The value of the entire expression is 1, which is discarded. Discarding the expression's value is no great loss since the reason for writing the statement in the first place was to modify I. And boom, we are on to the expression, or the exercises. All right, you guys, let me go back up to the top here. That was a lot of reading. All right, you guys, thanks so much for joining me today. That was chapter 4, expressions from C, Programming a Modern Approach by K.N. King, 2nd edition. I appreciate you guys for being here and joining me. This was the live stream. If you guys want to see the condensed version, I will be uploading a audiobook kind of chopped up style, getting rid of all the stutters and whatnot, and note-taking just so you can get a fluid read-through of the entire chapter to listen to on your commutes or wherever. I find those to be very helpful. I've actually been listening back to them and revisiting the material on my commutes as well. If you guys have enjoyed this stream, please leave a like. If you enjoyed the video, please leave a like. Thank you guys so much for being here, and I'll see you in chapter 5 in the next one. Bye, guys. All right, that was the end of the video, but not the end of the stream yet. I will end the stream here in a second, but I'll just answer a few Q's and catch up on chat before I go. What's the best thing that can happen to you today? I don't know. I don't know. Nothing really good happened today. I kind of just went to work, and now I'm here. I appreciate you guys being here and joining me. I will stop the recording, actually. There. Cool. So I will go ahead in the next stream. I'm probably going to take a break from the book for next stream, and we need to take a stab at the MIT OpenCourseWare problem 60002 for problem set 4. Yeah. So we need to do problem set 4 for MIT OpenCourseWare 60002, which is the Introduction to Computational Thinking and Data Science course. So we will be doing that one probably tomorrow. And we also need to go back in through the chapters of our Introduction to Algorithms book and complete the practice problems and stuff in there as well. That one's a little bit less on the agenda as I'm kind of wanting to get, reinforce my learning in C and stuff and then translate that into algorithms and whatnot. But we will obviously, try it nonetheless. Any... Okay, let me just, we'll go here. Reading chapter 4. Cool, so if you guys want access to my notes, you guys can find them on my GitHub link down below in the description. I've got really great detailed notes with good examples taken from the book and screenshots straight from the book. If I didn't take any notes in that section, it's because it really wasn't that relevant to any notes that needed to be taken, really. So But I really try my best to be authentic and transparent with you guys and what I'm learning, and have it all here for you guys to also learn as well. So if you guys enjoyed this one, please leave a like look at the notes on GitHub. This was chapter 4, so this one was awesome. We'll jump into the exercises over the next couple of days. Let's see here. We're going to do stuff like show the output produced by the following program. So kind of evaluating expressions, right? Seeing what the order of operations that C does, precedence, and associativity. So we're going to get some good practice with that for sure. I remember in a previous stream you mentioned you first struggling with coding. What did you do to overcome this? Um, Honestly, dude, like the genuine 100% real answer that a lot of people will tell you that is the truth of it is, dude, you've got to just code. Even like I can sit here and read out of the book like all day long and get practice, but without actually doing the practice problems, like I'll forget it in a week. Like it'll be gone, or 2 weeks, it'll be gone. Like you have to do that actual practice to really like set the material into your mind. Like think of like the practice as like literally just like nailing that in, just boom, boom, like and like and then revisiting like in 2 weeks time. Like don't do the practice and then revisit it again in with some distance. Like that's how I was pretty successful in college, is like I was really like methodical about my studying, and like and then making sure like I evenly spaced out when I was revisiting the topics of past lectures. And so I wasn't really like forgetting stuff. Now, as I've been out of college and all that chemistry stuff is not as fresh anymore, I'm pretty weak in that realm, because it's really, I don't use any of that kind of computational chemistry, math-based chemistry stuff in my current work, as I'm actually doing like physical formulations and actually real world product building and stuff like that. It's not kind of theoretical, you know, problems and texts anymore. It's more real world chemistry stuff, and troubleshooting live products, and investigative testing and stress testing and all that kind of jazz, shelf life predictions, and you know, I do use some math for like chemical computations for my matrices and stuff like that. So, um, but definitely not stuff I've been actually learned in college and all that jazz. The lab, honestly, the stuff I've carried over the most in my industry is the lab courseware, like understanding the lab instruments, lab etiquette, because that's a large portion of my job is in the lab and stuff. So that's really where you learn a lot of what's actually in the field. But it's real, dude. Like you can see it on my channel. It's proof in the pudding. Like I started from nothing, literally zero, and I just by me sitting here day in and day out, even days I didn't want to do it, and just turning on the stream and just forcing my fingers to just write code. Like even if I like just wrote like a 30 minutes, like it's just that solidification and compounding day in and day out really helps to keep these materials fresh. Like I'm able to remember things about these languages in a more detail, because I'm hitting them over and over and over again, rather than just reading about it once and then forgetting it. Like I'm it's a different type of studying, um, for sure. But like I said, the genuine answer is you got to just show up day in and day out, and actually write some code and projects. And I often get this question, and a lot of people have this question, and I did have this question at the beginning, is well, people say to write code, but I don't know what to write. I don't know what project to make. And honestly, like I don't really have any advice for like what projects to make, because this is not I'm not gonna this is not me, like I'm not trying to be malicious or mean or anything, but like it's honestly like coming up with the project ideas. Like it's just kind of like a skill issue at the end of a day, or like a way of thinking issue rather, like, and not in a malicious way or a mean way, but just like you maybe don't have like the experiences in like real world real fields or your hobbies or whatnot, to where you're you have situations to want to write code for those types of implementations. Like I would have never been able to write the chemical matrix linear programming solver that I wrote for my work had I not actually gained that experience in that profession, doing those by hand over and over and over again, and realizing, man, this sucks. I want to do this with a computer, and it'll probably be way better. Like, and so that sparked that interest, and that's what started me to go down this route and learn how to program, honestly. So, like, I would try to just gain some real world experiences, whether it be in college, socially, like, social media, that's like socially, um, academically, I don't know, psychologically, like anyway, like it seems like its code is starting to evolve into all these types of fields now. So just gaining some life experiences, actually doing things outside of code to then bring into code, I think is really it helps out with the projects. But that's honestly all I can really say about how you can come up with these project ideas, because honestly, a lot of my project ideas just come to me as I'm sitting in traffic thinking about what I have to do that day, and like about my hobbies, like about stocks, about spectroscopy, chromatography, chemistry, um, about business, the small business manager, and Birdie Rose clothes. Like these are just my hobbies that I've then have translated into code due to real world, real life experiences. So yeah, that's all I can really say. Hopefully that wasn't much of a rant. And again, like when I said like a skill issue or skill gap, it really was not in terms of like a malicious intent of anything like that. It mainly was a lack of experience, like in terms of like life event, to maybe provide you the insights on what maybe to make and what you want to make. And that gap is something that you can fill by gaining skills. So yeah. I often think that that word has like a negative connotation, or whatnot, or that phrase, but I didn't mean it like that. It's more of like a literal, like a gap in skill that needs to be filled by experiences of doing something, of anything really, out in life. And that's where you find the most value in things, I think. Like that's what I've been reading a lot of, like founder talks and listening to a lot of like stuff like that, and they often say like the best workers and founders are the people that actually worked in other adjacent fields and then brought code into their passions, right? Rather than that, because it brought that kind of like customer point of view, real world use case point of view to solve a problem rather than to make money, right? Something like that. Anyways, that's my rant, my ramble. Sorry. um, what's your motivation for learning C as a biochemist? Is programming secondary area of interest for you? Yeah. So I was learning programming in general to accomplish this project at work. I have to balance a series, or a vector of chemical serums within a single blend, and figure out what blend, according to a bunch of different parameters like FIFO and you know and just would meet this suite of ranges for like analytical constituents such as like protein or cholesterol or things like that, for lack of better words. um, and so like if I blend these constituents together in various forms, what would the predicted yield be of all these constituents within them? And so I wrote this program with another guy to mathematically compute a balance using linear programming to in linear algebra to like or yeah, to basically find a point within the graph or the curve that all of these parameters or constraints are met to satisfy like the overall volume constraint. And because of that, that's what sparked my interest in learning to code, and I was actually successful and able to write that this past couple of months. It took like a whole year to really get my learning up and figure out how to do it, and then uh, and so now I finally got to a point where I was comfortable with writing code to be able to tackle it, and we did it. And I built like a whole GUI for it and stuff, and I'm gonna try to implement it on my next go around, and so we'll see how it goes. And yeah, that's pretty much it. And then it's kind of like waterfalled or snowballed from there, and just wanting to learn more and finding interest in computers in general. And yeah, so anyways, I appreciate you guys being here and hanging out with me. I'm going to go ahead and sign out for today. If you guys could leave a like on the stream if you're here, it's completely free. Just hit the thumbs up right before you go. Thank you guys so much for being here, and I'll see you guys in the next one. Thank you, Ray, Ethan, Force, Siksham, all y'all, Zortaruno, who else was in here? Tim, Redwan, Ahmad. Hey, I'm a new programmer. I'm taking data structures and struggling. Do you have any recommendations or tips I can learn? Um, uh, I learned a lot about my data structures honestly through practice with them, understanding Python objects and how they're being like the underlying data structures that are actually being used within them, and then actually using those data structures, like using dictionaries or hash maps to store my data in my projects, or using sets to filter out my data of duplicates in my lists, or like or whatnot, like understanding building queues and like building decks and whatnot, and also just reading data structures and algorithms in Python. I read about the first, like, I think 11 chapters live on stream back last winter. So if you want to go back into the previous streams and watch those, feel free. That'll probably help you out. I also have notes on those books, on that book as well on my GitHub. So DSA and Python. All right, you guys. I'll see you guys tomorrow. Thanks so much for being here. I do have an idea of a project I want to start and see once we get some more functionality learned. I would like to write a project where it displays you an image, but it pixelates it according to various kind of an average pixel per quadrant, and then we will make a guess about what that image is, and then if that's wrong, it will go ahead and reduce the quadrant size by a factor of some, and then find the new pixelated average to kind of blur the image on a reduced level. And then eventually, as you guys can see where I'm going with this, the more and more guesses you do to the image, the more and more clear the image becomes to where you can finally guess it and maybe get it right. I think that would be a cool game to kind of implement, because it kind of reminds me of a project that we did back in CS50 with the filter and the blur and whatnot. So I think maybe that would be fun to get into. Hey, thanks, Pointer. I like that name, Star Pointer. That's a cool name. Thank you so much for being here. Be cool, like maybe someone have named Char Star. That's awesome, man. You're 100% right in finding projects through life experience. I didn't really have the motivation to code outside of high school. I found a couple of things to work on. So yeah, awesome, Ethan. Thanks so much for joining me tonight, dude. I'll see you tomorrow. Come back tomorrow. Let's go together. All right, you guys. I'm